Today we're in the Chapter 5 AP Chemistry Notes on page 3, and we're going to start off with understanding how to design a two-condition problem for gas laws. What you need to do is you need to read a problem and figure out what variables are used in the problem and then design your own formula from this general formula right here. So this is pressure times volume over moles times temperature in one condition equals the pressure times the volume over the moles times the temperature of a second condition. So if you read problem number 1, it says a 2-liter balloon has a pressure of 3 atms. So you could see that the volume is 2 liters, the pressure is 3 atms, and then you're looking for a new pressure and a new volume. So what you're going to do is you're going to design a formula with pressure and volume. So you look over here and it's P times V equals P times V. So this is the formula you would use for that. And we'll go over how to set that up on the bottom of the page in a few minutes. Now number 2, when you read that one, you'll see that this has a balloon of volume 10 liters and temperature of 30 degrees Celsius. And then you're going to have a new temperature and a new volume. So now you're designing a formula with volume and temperature. So that would be V over T equals V over T. So this is going to be a fraction set up like this. All right, the third one, you have a pressure of 2 atmospheres in a helium tank and a temperature of 20 degrees Celsius, and then you're going to change the pressure as the temperature changes. So the temperature and pressure are changing, so you go over here for pressure and temperature. So it's P over T equals P over T, and that's over here. Okay, for number 4, you're going to see that you have a volume of 16 liters, a temperature of 40 degrees Celsius, and a pressure of 600 millimeters of mercury. And now you're going to have a new volume and a new pressure and a new temperature. So it's volume, temperature, and pressure. So you have to go over here and you design a formula which is P times V over T equals P times V over T, which is right here. And lastly, number 5, you could notice that we have a volume given and a number of moles given, and then a new volume and a new number of moles. So now you're going to design a formula with volume and moles. It's going to be V over N equals V over N. So for all these problems, what you need to do is read the problem, figure out what variables are changing, and then set it up from the general equation given above. Each of these happens to have a special name. It's called Boyle's Law, Charles' Law, Gay-Lussac's Law, the Combined Gas Law, and Avogadro's Law. So now that we understand how to set it up, you can simply do the math below. So we'll start with number 1. We said that number 1 is going to be a P1 V1 equals P2 V2. So the first volume, you can see right here, is 2 liters. So we're going to write 2 liters over here. The first pressure is 3 atms, 3 atms. The final pressure is what we don't know. And the second volume is 1 liter. So when you do the math for this, you're going to find out that this comes out to be 6 atms. Now let's take a look at this a little further and understand what's going on. The pressure in the balloon was 3, and then the volume was 2 liters, and then what happens is you took the balloon and made it smaller to 1 liter. So you cut the volume in half. You made the balloon get smaller. So if you make the balloon get smaller, the pressure is going to go up. That's called an inverse relationship. So pressure and volume up here are inversely related. This is inverse because when one goes up, the other goes down. Now let's take a look at number 2. Number 2 has volume and temperature. So we designed our formula as V1 over T1 equals V2 over T2. So let's take our first volume, was 10 liters. Now you have to be very careful, and you see the note up here that you always have to use Kelvin whenever you use a temperature. Okay? If you use Celsius, you could just go ahead and mark that wrong because it will definitely be wrong. So you have to change this into Kelvin. So it's going to be 303 Kelvin. And then you're going to have a new volume, which is 20 liters. And you want to find out at what temperature will that have to happen. So if you do the math, you're going to find out that that's 606 Kelvin, which is actually quite high. So the interesting thing is that this is a direct relationship because as the temperature went up, specifically doubling here, the volume also went up, which also happened to double. So that's called a direct relationship. Okay, I'll go ahead and continue to set up the problems over here. If you feel comfortable setting up the problems, you can go ahead and pause this and set them up yourself, and then fast forward to see if you set them up correctly. In case you're having trouble, I'm going to continue to explain each of them. So the third one is going to be pressure over temperature equals pressure over temperature. And we'll plug them in as the first pressure is 2 atms. Again, you have to change the temperature to Kelvin, so that's going to be 293 Kelvin. And then this is going to be 303 Kelvin. And this one's going to be the new pressure, which we don't know. So now you're probably going to have to use your calculator for this. And you're going to take 2 divided by 293 times 303. And you're going to come up with 2.1. When you round it to 2 sig figs, 2.1. Okay, the fourth problem is going to be P1 V1 over T1 equals P2 V2 over T2. I'm going to have to move this up a little bit. So 16 liters is the first volume. 40 degrees Celsius, you have to change to Kelvin. So it's going to be 313 Kelvin. And then you're going to have 600 millimeters of mercury. You'll notice that I'm just using the units they gave me. I'm allowed to use any units I want as long as I match them. So 500 millimeters of mercury. And you got 50 degrees Celsius. So you're going to get 323 Kelvin for that. And lastly, you're going to look for the volume. Now you just do your algebra, 600 times 16 times 323 divided by 313 divided by 500, and that's going to give you 19.8 liters. Okay, and the last problem is going to be V over N. So V1 over N1 equals V2 over N2. The first volume is 24 liters. The first moles is 9 moles. Oops, 9 moles. And then you're going to have 18 moles down here. And you're going to solve for volume, which you shouldn't need a calculator for. It's going to be doubled, 48.0 liters. Again, this makes sense that this is a direct relationship because the more moles you have, the more volume you're going to need for a balloon, let's say. So these are what we call two-condition problems, and you can design your own formula, and as long as you understand that you can use any units you want except for Kelvin isn't mandatory, then you're fine. So match your units except Kelvin no matter what, and you can also tell that this is a direct relationship between pressure and temperature.